All right, what we have here is a tutorial on how to write formulas. If you are still unsure of how to identify whether something is ionic or covalent, definitely suggest you go back and watch those videos because that's going to be really important, as we're going to see here. So what I have here are just 3 sample problems that we want to kind of work through here. Just writing the formula. So we see the name here, calcium oxide, and we're gonna we'll definitely want to use this cheat sheet here. So we always want to start at the top of these flow charts. So when we look at this, the first thing I want to look at is, does it start with a metal or ammonium? Remember, ammonium is NH4, so it's kind of like an exception to the rule. So everything else, if it's a metal, and again, if we're not sure what metals, non-metals are, go back, kind of watch some of those earlier videos. But when I look at this, when I look at calcium, what I in fact see, I see calcium, and I know if I look on the periodic table that calcium is in fact a metal. All right, so I'm going to go to the right. All right, so I'm just going to follow my flow chart here. Yes, it's a metal, so that tells me right away if it's a metal. It's on the left side of the periodic table. It's ionic. So I'm going to go through these steps one by one. So step 1, I'm going to write down the chemical symbols for the 2 ions that make up the compound. So I just write the symbols. I'm going to look those up using my ion chart, and I want to make sure that I include those charges. If it's polyatomic, I'm going to put it in parentheses, and let's identify one of them right now. So what I'm dealing with here in the problem is I'm dealing with calcium, right? So here's my calcium, and it's calcium oxide. So I just look those up. There's always going to be a positive paired with a negative, opposites attract. And I'm just going to look those up, and I'm going to write out those ions. Now, when it talks about putting a polyatomic in parentheses, you can see some of those here on the bottom, right? If there's more than one element, we call that polyatomic. But for this first example here, we've just got 2 monoatomics. We're going to note these charges. So Ca is a +2, oxygen is a -2. All right, so I'm going to start off, I'm just going to write that, and that's what you should always do when you start one of these ionic formulas, is we're going to write out the charges. So I got Ca +2, oxygen is a -2. All right, now I'm going to go to the next the next step here on our cheat sheet. Tells us that we want to look here, and we want to balance the positive and negative charges in the formula. So it tells us what we need to do. We need to drop the positive and negatives. Basically what we're going to do is we want to have these cancel out. We want them to kind of have a net charge of 0. So this is kind of a shorthand way of figuring out what that formula is. So we're going to drop the positive and negative charges, signs on the charges. We're going to switch the numbers and write the number after the element symbol. And then we drop that down into the subscript position. So I like to use drop and swap. Other teachers call it drop and flop, crisscross. There's a bunch of different names for it. But here's kind of an example of what it's going to look like right down here in the bottom. So we see in this example, iron has a charge of +3, oxygen's a -2. They're basically, we're getting rid of the charges on those, and then we're just swapping those numbers, and that tells us what our formula is going to be. And then we want to reduce those numbers if necessary. Obviously in the example 2 and 3, we can't reduce that. So let's go back to our example here that we're working on, and we have Ca +2, O -2. What I'm going to do is I'm just going to, again, just like that example, I'm going to get rid of the charges. I'm going to drop those numbers down and swap them. Now, they end up being the same number here, so they both end up being 2s, but obviously if it was a different number, if this if the oxygen was a 1, well then calcium would get the 1. So when we look at this example though, well, this is an instance where we can see that we can reduce this, right? We see that these are both 2s, so we can reduce that. We can take a 2 out of there, and we can reduce it to ones. And we don't write ones, lazy chemists. We would just write that as CaO. All right, so let's take a look at the next one here, copper 2 hydroxide. So when we look at this first thing, as always, we want to look at copper. Is copper a metal or a non-metal? And look on the periodic table. We see that it is in fact a metal. So if we go to our flow chart here, what we see is that, does it start with a metal or ammonium? We always want to start there. Yes, it does. So again, another one ionic. We're going to do the same steps that we did before. What I'm going to do is, I'm going to write down the symbols using that ion chart. We always want to start by writing those ions. Then we're going to do that drop and swap business. We want to bring those charges down, get rid of the charges, and just rewrite the numbers. So let's look at how that's going to look here with copper 2 hydroxide. So the thing about copper 2, we could have what this Roman numeral is telling us is what the charge is on copper, right? So copper, Cu, could have a couple of different charges. It's a positive, but it could be positive 1, it could be positive 2. It changes. So like you probably learned in the naming video, we have to identify what that is, and we do that with the Roman numerals. So in this case, when we see the Roman numeral 2, that tells us what the charge is. We don't even have to look it up because we know copper 2 is going to have a +2 charge. Hydroxide, we probably have to go to our ion sheet to actually look that one up. Okay, so here's my ion sheet, and let's see here. Here's my copper 2. We can kind of confirm that that is in fact +2. And now I've got to find hydroxide. Now hydroxide is one of those polyatomics. Notice how there's parentheses around it. That's going to be really, really important for when we solve this problem. So I'm going to finish this up here. I'm going to add my OH -1. Right? And I want to make sure that I have those parentheses. If I don't have those parentheses, it's going to screw everything up. So when I actually go to write this formula, I'm going to do that drop and swap method, and I'm going to end up with Cu1. I don't have to write the 1, so I'm not going to. And in parentheses, I'm going to put that OH, and the 2 is going to come from the copper, so I end up with a formula that's Cu parentheses OH, close that parentheses 2. So that tells me it takes 2 OHs to cancel out that 1 copper. All right. Now that's going to be a lot different than if I write that without the formula, or without the parentheses. Excuse me, because that's saying that I only have 2 hydrogens, not 2 OHs. So make sure that you have those parentheses. That's really, really important. So the last example that I have here is we're going to look at. We're going to look at carbon tetrafluoride. So my first element here is carbon, and if I go back to my flow chart, look it up, is it a metal or a non-metal? Remember, that's our first starting point. I'm going to see that that's our first non-metal, right? So that's a non-metal. So we're going to go down the opposite side of the flow chart. So now we have a whole new set of rules. So does it start with a metal? No, it doesn't. So this is going to be covalent. Now, a totally different set of rules. We're going to write down the chemical symbols for the 2 elements in the compound. Well, let's go back. What are my two elements in the symbol? So it looks like I have carbon. That's easy to see. And then I see fluoride, and then I see this tetra thing. And that's another indicator that it's covalent. Anytime we see those prefixes, and if you start to learn those, you kind of recognize them, that's a big red flag, big indicator that, hey, this is a covalent compound. But I'm just going to follow, again, the flow chart here. Fluoride is fluorine, F, and we get that off the table. So let's go back to that flow chart. My next step would be to look at the prefixes in the chemical compound name. Those tell us how many of each element is present. So we can use this chart down here to help us identify how many of each there are. Now the big thing here is to keep these separate. What a lot of students are going to do is they're going to look at these prefixes, and then they try to swap them. All right, don't do that. Make sure that when we come back here to our our formula, we're looking, I don't see a prefix in front of carbon. So what do? I can look up on my sheet here tetra, but I don't know what carbon is. So let's address that. The last part of this, you're almost there, is that if there is no prefix on the first element, that means that there's only one atom of that element present. So when we look at just carbon, and just to point out so I don't have to flip back and forth, there's tetra. Tetra means 4. When we look at this example, there's nothing in front of carbon, so that means that there's just 1. Now we don't write the 1. I'm going to put it there just so you know. Tetra means 4, so we have 1 carbon, we have 4 fluorines. So when I write this out, this is going to end up being CF4. Okay, I hope this helps you write formulas. Make sure to let your teacher know if you still have any questions.